The volume formula for a cone. Check this out. Look at this picture here, Dalo. Can someone tell me the volume formula for a cylinder? Before look at the cone. There's some liquid or sand being from a cone into a cylinder. What's the volume formula for a cylinder? Can someone just tell me from the reference sheet for a cylinder, not a cone? This, right? So this is for a cylinder. And notice the cone. The cone, this circle, assuming that this circle is the same as that circle, how much, if I filled up the cone and put it in the cylinder, how much of the cylinder has been filled? 1/3. So look at, if it's one cone filled and I put the amount of volume into the cylinder, it's actually 1/3 the cylinder. Look at, here's 2/3 of a cylinder. Look at 3/3 of a cylinder. So I know that for a cone, it's the volume of a cylinder times 1/3. Think about that. Think of the volume. Fill up the cone, pour it in the cylinder, that's 1/3 of the cylinder. 2/3 of the cylinder. Fill up the cone again, pour it in, 3/3 of the cylinder, a whole cylinder. So that's why you have the cylinder or the cone formula for volume is going to be, as you see on your reference sheet, 1/3 area of the base times the height. Because it's assuming you have a cylinder, it's going to be 1/3 of it. That's the logic. We don't have to be afraid of fractions. You know how to do fractions. Come on now. There we go. Volume then, 1/3. What is the area of the base of? Right, so what's the area of the base? How do you find the area of the base? Right, so it's pi, look at this. Pi r squared, huh? That's the area of the base. That's the area of a circle. And then the height is, how tall is it? 6 inches. Look at from here to the center, right angle. 6 inches. Rocking and rolling. All right. So the volume then is approximately 1/3 times 3.14 times the radius, in this case is 4, squared times 6. Okay? Go ahead and try it on your own for about a minute. Did you finish yours? Did you finish? How about you? Did you finish? Following the volume. Did you do this all on your own yet? What'd you get, Miss Buta? Okay, I'll give you about a minute. What'd you get, Hurtado? Okay, what'd you get, Castillo? All right. So I'm gonna put the 1/3 off to the side right now. Let me multiply all this stuff out. So this is gonna be 3.14 times 16, because 4 to the second power becomes 16 times 6. Let me multiply all that garbage out. I got 3.14 times 16 times 6. I got 1/3 times 301.44. So the volume then is approximately 1/3. Well, let's make 301.44 into fraction. Just put a 1 underneath it. So I really have 301.44 over 3. Cool. And so the volume then, I'll divide that by 3. 100.48. Hurtado, you said it. What kind of units? Nice. Cubic inches, huh? Cubic inches. What is a cubic inch? That's the volume. I'm asking, what's 1 cubic inch? What is a cubic inch? If a little kid came up to you and asked you, what's a cubic inch? What'd you tell him? Boo! Look at it. I'll tell you what a cubic inch is. Look at it. It's a cube where every edge is 1 inch. What was this right here? Remember, I passed it. I'm going to pass this out shortly, too, after we're done with our notes today. What are these? Cubic what? In my hand is a cubic what? It's a cubic centimeter because every edge is a centimeter. So cubes can get bigger or smaller. So we're saying cubic inches fill up this cone. Get a piece of paper out for notes. I'm going to only go over 2 examples in the notes today. Very simple.